Now, remember, you have to memorize 8 of the polyatomics that are on this sheet. You have 5 of the different ones that are 8s. They are nitrate, carbonate, sulfate, phosphate, and acetate. Those are the 8s, okay? You also have to know hydronium, hydroxide, ammonium, and what's the last one that I forgot? I'm forgetting. No. Oh, I'm sorry, I forgot chlorate. Chlorate is also one of the 8s. So chlorate, nitrate, carbonate, sulfate, phosphate. And then you have ammonium hydroxide. Don't forget acetate as well. Those 8 are one of, I would say, the most common frequently used ones that you'll see. Even if you read food labels and things, you'll see them pop up from time to time. But the other 20 or so that are on the chart, this chart, remember, these ones you don't have to memorize. We will provide you this chart on the quizzes and tests. You just have to be able to use them, okay? These are also common ones. They're not as common as the other 8, but we will be using these as well. You will be provided this table, okay? Now, for 5 of the 8s, there is a way to remember if you want to use this strategy. You can go to flashcards. You can, repeat them to yourself in the mirror. Whatever study strategy for memorization works best for you. For me, I like to write it down like 5 or 6 times. That usually solidifies it for me. But people that are good with words, they come up with creative ways to remember things. And this one I found, and I thought it was kind of nifty. So basically here, of course, the 8 part right here is to tell you that this one is going to work with 5 of the 8s that are on your list. Now, the first letter, of course, is going to be the first letter in the formula. And for clam, Cl, that's going to be chlorine, okay? So here, basically you're looking Nic, N-I-C-K, has 1 vowel and it has 3 consonants, which are the non-vowel letters. If you aren't familiar with that word, that's what we're talking about there. So basically, for this one, this would be N, which would be N. Now, there are 3 non-vowels, the N, the C, and the K. That is the number that I put on the oxygen. So this would be O3. And the number of vowels in the word is the number that goes into the charge. So because there's only 1 vowel, the I there, this would be minus. So that is the formula for nitrate, and O3 minus. Okay, so here camel, this is going to be C. How many non-vowels do I have there? 3, so that's O3. That's the number that goes in the oxygen. How many vowels? 2, so the charge is 2 minus. Clam, this is the Cl one. How many non-vowels or consonants? 3, so O3 and 1 vowel, minus 1. Supper, S. 1, 2, 3, 4, O4, 2 vowels, there's sulfate. And Phoenix, you have P and then 1, 2, 3, 4, O4, 3 vowels, minus 3 for the charge. I thought it was cute. You don't have to use it, but it is a method of learning 5 of the 8 that you need to know. And you could try to create a way to remember hydroxide, OH minus, ammonium, and H4 plus, and acetate, which is C2H3O2, which is probably the hardest, minus 1. But that's one trick you can use if you want to, or you could just like stick with regular like flashcard type methods. Okay? Very good. All right, so now we're going to do, we wrote the formulas. No, I'm sorry. Yes, we wrote the formulas from the names. Now we're going to do the names from the formulas. Very similar to binary. Here we are going to look at our cation just like we did before. So, Ba, what's our cation name? Ba is barium. What do you do, the dead chemists? Give barium. All right. So we have barium. Now, I always ask myself at this point, is barium a multiple oxidation metal? Is it going to get a Roman numeral? No, it's in group 2. It's alkaline earth metal. Now, here I have OH. Which polyatomic does that one go with? What's its name? What's OH?
Hydroxide.
It is hydroxide. Very good. So we would write out hydroxide here. We don't have to do any calculating because we don't have to figure out a Roman numeral. So this one's name is just barium hydroxide. Very good. Now let's look at the next one. What's Fe? Fe is iron. Good. Is iron a multiple oxidation metal? Yes, it is. So now we do have to do a calculation for this one. But before we get there, what is PO4? Which one is that polyatomic?
Phosphate.
That is phosphate. Very good. So we would write down phosphate here as the anion name. Now, let's always start with the anion. What's the charge on phosphate? 3 minus. So we have 1 times minus 3 plus 1 times X equals 0. So what is this charge going to be on our iron? Has to be 3 plus. Good. To make it balance out to 0. So our Roman numeral for iron will be 3. Then you can write out the name. Iron 3. And you can write your Roman numerals like that, and you can do it without the parentheses if you don't want to. You can write them like that. That also is fine. Phosphate. Remember, all the Roman numeral is telling you is what is the charge on that multiple oxidation metal. Okay. Let's do one more, and then I'll let you practice. HgNO3. What's the name of the cation? That is mercury. Good. Is mercury a multiple oxidation metal?
Yes.
Yes. Very good. And what is NO3?
Nitrate.
It is nitrate. Good. Now, we have nitrate's charge. What's nitrate's charge? It is -1. So we have 1 times -1 plus 1 times X equals 0. So our charge on the mercury is going to be +1. So our Roman numeral should be a 1. So the name here would be mercury 1 nitrate. So go ahead, take about 5 minutes or so. Let's practice some of the other ones, and we'll come back and go over the answers. This one right here, check your answers. This is going to be sodium. Sodium a multiple oxidation metal? No, it's not. Good. What is CO3? Carbonate. So that's easy enough. All you have to do is pair those together. Sodium carbonate is our final answer for that one. All right. Ba is barium again. Barium, we already said, is not a multiple oxidation metal. What is C2H3O2?
Acetate.
Acetate, very good. For your information, too, acetate is one of the components in acetic acid, which you know it as vinegar, and we use it all the time. So that's one of the chemical components of vinegar. All right, we don't need to do that, so we write out our barium acetate over here. Okay, couple more to go here. NH4, what's that? Ammonium, and ammonium is a cation, so obviously the multiple oxidation metal part is not going to apply here. SO4 is sulfate. Okay, so all you have to do is put those two together as the name, as I write too many loops in my M. Here we go. Ammonium sulfate. Very good. Next one, though. Oh, this is an interesting one. Cu, what's that?
Copper.
That's copper. Copper is a multiple oxidation metal, so we're going to have to calculate that one. CO3 is carbonate. And a lot of people mess up on this particular type of compound, and I'm going to show you why. What is the charge on carbonate?
2 minus.
2 minus. There's one of them at 2 minus plus 2 of the coppers times X equals 0. So what is X here? It is plus 1. Good. So our Roman numeral should be a 1. A lot of people get that confused because the 2 is in the beginning on the cation. So when you write it out, copper 1 carbonate. And we have here Cr. What's that? Chromium. Chromium is definitely a what? Multiple oxidation metal. Very good. And PO4 is?
Phosphate.
Phosphate. So there's one of each. We know phosphate's charge is
3 minus.
3 minus. So obviously our chromium must be 3 plus. So we need a Roman numeral of 3 here. Chromium 3 phosphate. All right, that's the last one here, but I do want to address the hydride situation, so you might want to make a little note on your common polyatomic ion chart or something about hydride. It's kind of an exception example. So, H, we know it's above the alkali metals. It has 1 valence electron. You would safely assume it's like the alkali metals and it does a +1, right? We could all go with that. However, hydrogen's an interesting one because, yes, hydrogen has 1 valence electron and it can lose it and it can become H+, like that. Okay? But hydrogen can also gain an electron, and then if it has 2, it looks like helium, so there it also has the octet settled. It can be a -1. Now it depends on where it is in the compound as to whether it's going to be +1 or -1. So if you have a compound like this where it's HCl in the front and it's in the beginning, then it's acting as a cation, and that would be the +1, right? But if it's in something like this, MgH2 or something like that, where it's in the second half of the compound, like so, this case, you change the ending to IDE, and it's acting as the anion. So in this particular case is when it's going to have the -1 charge on it. Okay? Now we're going to talk about it when it's in the front later, because there's 2 different scenarios. If you have HCl where it's just a gas and it's just molecular, it carries +1. But also when it's HCl and it's AQ, we know this is an acid and that's an acidic H. It still carries a +1 on its charge, but they are 2 like separate entities. You have gaseous versus when it's dissolved in water, it acts as an acid. So hydride, it's acting as an anion, it carries the -1 in that particular case.